aiFace.launch, we get an interface where we just have to first provide the prompt, and then the output is going to be in the image format. And there we go, we get the anime image for the provided prompt. Alright, so before we even get to installing and importing the requirements, I just want to let you know that I'm using Colab Notebook, and I recommend you to do so as well if you don't have a GPU or the CUDA environment installed. What you can do is just first change the run type itself. Just click on change run type and then use the free GPU that is given to you by Google Colab in their environment. This also has the CUDA environment set up, so you can actually do computing with this free GPU that they have provided, which is actually required for this type of project. So click on save, and then now we can get to actually importing the dependencies that we need. So I'm just going to put everything in a single line by using the -q, and then I'm also going to upgrade if it's all I have anything installed already. So I'm going to start off with importing diffusers, and this is the one that is mainly responsible for generating images from the prompts that we're going to provide. And then we're also going to import transformers, follow that up with accelerate. Now this is a module which will make sure that there is low CPU usage when you're actually bringing in the weights to your local machine and actually training the model, which is actually what we want. We don't want to use maximum amount of our resources, which is very limited in this case. And then I'm also going to import safe tensors for similar reasons. So if you know what a tensor is, then safe tensors are just going to be the premium version of the tensors itself. It's just going to make sure that the memory is actually managed, and it also does extensive checking for errors, and we will explain this in detail when we actually get to that point. I promise it's going to make sense. And I'm also going to import radio as well, so let's just do that. This is for the interface. Again, if you don't know what that is, we will get to that when we actually type out code. So these are the models that we will need. So let's just run this code cell. Oops, we have to put this to be like this. Now run this code cell. Alright, so after all of the installing is done, we want to actually import all of them. I'm going to just start off with the diffusers itself. From diffusers, this is the library from where we can import the pre-trained models. I'm going to import stable diffusion. This will be responsible for giving us the required pipeline by using a pre-trained model. Again, this will make sense when you actually look at the code itself. Pipeline, like that. I'm going to just run this code cell. That's it. Now let's just get to creating the pipeline itself. So first, I'm going to define two variables, one for the model itself, and this is going to be a pre-trained model. So if you come to huggingface.models, you will get to see this pre-trained model, which is what you'll be using in this video. And in order for us to use this from the diffusers library, this is what we have to do. We have to import the diffusion pipeline and then copy the actual address and then put this inside a string format to load it from the pre-trained function. Let's just show you how. This is going to copy this thing itself and then get back here to our code, create codes, and then put this inside the text. And I'm also going to have another variable which will be negative prompt. So the reason why I created this variable is we have to make sure that when the prompt given by the user is provided to the model, certain set of words which are not actually required can be ignored, which I already have it copied. Like for example, let's say in the prompt given by the user, we see the word worst quality. Then we just want to inform the model itself that we don't actually need to look at these words. We can just ignore these. And those set of words has been put in here inside the negative prompt variable. I'm just going to provide this to the model. I'll just show you in a second. Now over here, let's just define our main model itself. I'm just going to call this an image generator, and then this will take in a prompt which will be given by the user. And inside this, we will first start by defining our pipeline itself. So pipe will be, again, just recall that we imported the stable diffusion XL pipelines. I'm just going to use that, paste it over here, and then use the from pre-trained function to load in the pre-trained model. And inside this, you want to first mention the model itself, the model variable that we created, which has the actual prompt for getting the model itself. After which, we want to mention the data type of the processing that we are going to make. And this will be a torch data type. I'm just going to have this to be float16 from the torch framework, that is PyTorch. I'm going to set this to be torch.float16. Again, we will have to import this. I'm just going to get to over here and then import torch. Run this console once again. After this, I want to use the safe tensors. Again, this will just make sure that there isn't any errors. It's just going to do extensive checking for errors and also make sure that the memory is actually being managed by itself rather than us manually taking care of it. So I'm just going to set this to be true. And then there's just one more parameter. Again, for similar reasons, I'm just going to set variant to be FP16. So there's going to be two variants available. One is the half precision and the other one is full precision. The half precision is just much more faster and it demands way less resources when we compare it to full precision. But then in full precision, there's going to be much more detail available. Now I've set this to FP16, which is again half precision. Now FP16 is just setting the floating point to a 16-bit rather than a 32-bit. If you prefer to have a full precision variant, then you just have to keep this to be FP32, but just keep in mind that this is going to demand huge resources. You will have to have a much stronger GPU. So I'm just going to set this to be FP16 for simplicity, and that's about it. We can just close it right around here. The pipe is created. Now, each time when you create a pipeline from Stable Diffusion, it is going to expect a scheduler. Now, scheduler is a very important component in an image generation project like this. So the idea is the model is going to generate a sample image from the given prompt, and before this sample image itself is provided as output, we want to make sure that we make the necessary refinements, and for this we will ask the pipeline that we created to iterate over the same image that was created as a sample for a certain number of times. And I'm just going to call this to be steps or inferences. And this scheduler will set the time of steps and how much amount of noise should be added or how much amount of noise should be removed from the sample image so that we get the perfect image that we're looking for after the number of iterations or the steps that is completed. There are just many schedulers available, and the one that we're going to be using is called the Euler Ancestral Discrete Scheduler. Thanks for the recommendation, Google Colab. Again, we haven't imported this, so we have to get over here and just put a comma over here and then make this. So just remember, whenever you import a Stable Diffusion model pipeline from diffusers, you also have to import the corresponding scheduler. I'm going to use the Euler Ancestral Scheduler. Now, there's going to be a lot of math involved in order to understand how this Euler Ancestral Discrete Scheduler works. But then what this does is, again, the same things that I mentioned earlier, and also it's just going to make sure that the processing is actually faster, but then again demands very less resources when it's compared to high-end models. So let me just set up the configuration. Of course, each scheduler is going to expect a configuration, and almost every single time you want to set the configuration of the traditional pipe scheduler itself. So what you can do is just type in pipe.scheduler.config. Now, if you don't understand what the statement does, it's just that it's actually initializing this discrete scheduler by giving the configuration of the traditional pipe.scheduler, which will have a dictionary of certain parameters already defined, and we're just giving that to the actual scheduler that we're creating. Now, I know that is a lot to process, but then if you still feel like you need more info on scheduler, then I'm just going to leave a link in the description box below. That will get you to the actual schedulers page itself from Hugging Face, where you can go through everything that is available. Now, after this, you want to type in pipe.to and then mention CUDA. This is going to make sure that you're using the GPU environment. And then I'm also going to set pipe.interference batch size to be just 1. Now, this is actually just to make sure that we don't run out of resources when the actual processing is happening. We're just setting the batch size to be a very small number so that the processing is actually going to be faster and it demands very less resources. Again, all of this that I've done here are just to make sure that we use minimal amount of resources, because we are limited to the resources that is available, because Google Colab gives us a GPU which is not really that much powerful, but then which should be able to handle this project in specific. So with all that said, I'm just going to actually create the image itself now. We have the path ready. We also made sure to set up the scheduler itself, and then we made sure that the CUDA environment is active, so we can just directly use the pipeline that we created. And inside this, you first want to provide the prompt, which we will get from the user, after which you can also pass in the negative prompt, which will be equal to the negative prompt variable that we created. This is just to ignore the words from the actual prompt given to the model itself that are actually not required. I'm going to set the width of the generated image to be 512, and then also the height of the generated image to be 512. And I'm also going to set up the guidance scale just to provide a reference to the model itself. I'm going to set this to be 12, and then we have two other parameters that we have to mention, and they have to be a tuple. One is target size, which will be 512, 512. Make sure to put this inside a tuple, and then we also have to mention the original size, 4096, 4096. So we have to bring it down from 4096 to 512, and then the number of inference step which we can mention, but then the time of each step will be determined by the scheduler itself, and the amount of noise and everything will be decided by the scheduler, and hence we will just get the final processed image as the output. So I'm just going to set number of inference steps, which will be 50, like that, and then this is going to give us the image itself. This pipeline will generate an image in the form of a list. So in order for us to get the image alone out of the list, we just want to type in images of 0. This is going to give us the image itself, and we're storing that to image. Now all that we have to do is just return this image so that we can put that on an interface using Gradio. Oops, we have to put a comma over here. Now let's just run this code. So this didn't take a lot of time to run because all of the processing, we've just put that inside a defined function. So only when we call the actual function itself, all of the processing is going to happen. So let's just create the interface directly and then pass in the function that we created. So in order for us to create the interface, we will need to use Gradio. So I'm just going to import Gradio SGR. Again, if you don't know what Gradio is, we have a complete separate video for this one. I'm just going to link it up in the cards. SGR. Actually, let's just run this code and create a new one. Once that is done, you want to get to the interface itself. I'm just going to call this to be iFace, which will be use the Gradio interface function. This will create a blank interface, which will accept by default 3 parameters. One is going to be the function, what type of interface does it expect, what is the actual interface going to do. It is going to perform a function that we created, an image generator. And then we also have to mention inputs and then outputs. So inputs, it's just going to be text. We have to get the prompt alone, and then this input is going to be provided to the animate generator function, and then the output will be in the format of image. So just going to set this to be image, like that. And then first let's just run this to actually load in the model itself. This is going to take a lot of time when you're actually doing it the first time, because it's going to install all of the pre-trained model weights onto your local machine. So when you run this, oops, I forgot to launch this. You have to type in iface.launch and then now run this. We get an interface where we just have to first provide the prompt, and then the output is going to be in the image format. I already have a prompt ready. I'm just going to paste it over here. When you click on submit, oops, throws an error. Just type in debug equal to true. Then run this, paste the same prompt once again. Now look for the error. Name model is not defined. Oops, we forgot to run this code cell. And then after that is done, you want to run this code cell once again. Now get over here and launch the interface once again. Now provide the prompt and then submit. Now it's going to actually process. So it's going to take a while to actually install the weights itself from the pre-trained model to your local machine. At this point is where you have to ensure that your memory or your GPU is actually not going off of the limit that you're provided with. Just click on the settings over here to see how is it working. As of now, everything seems to be under control. Oops, we get an error. It's not defined. I'm sure we run that code out, right? Let's just run this once again. This is actually imported. Oops, we have to stop this one. It's gonna go above. Okay, so now I'm sure that this has been imported. Let me just run this and get over here to run this once again. Please, for God's sake, work this time. Write the same prompt. Now notice how the second time we didn't actually have to install the weights because we already have it installed onto this local machine. So it's going to directly import the components and then going to start to process with the text that has been provided. It's going to show us the number of inference steps. There you go. We see that the inference has actually started. After the 50th step, we're going to get the image itself. And there we go. We get the anime image for the provided prompt. Now I'm also going to set this as an example in the interface. Let me just get over here and type in examples. Put this inside a list. Have this to be 1. I'm also going to have another one. Actually, let's just put this in the next line. Control V, like that, then run this code cell. Now you see that we get 2 examples or suggestions for the user itself, which they can try by clicking on it and then clicking submit. Let's just try the second text this time. Again, it's going to take 40 seconds to process itself. Again, notice it's just going to load in the components first, and then it's going to get to the actual generation itself by going to the inference steps and completing 50 of them and give us the output itself, which for me in Google Colab takes about 40 seconds. 50 is complete, and there we go. We get the image for the second prompt as well. Now you can just play with this and get as many prompts as you wish and then get the image itself.